What is BFS? BFS stands for breadth first search. Basically, it is the algorithm which is mainly used for the traversing of the graphs and trees. BFS mainly looks for its neighbors first, and after that, it goes to its neighbors only, and not like going to the depth, unlike the depth first search. Let's see some example. Let's suppose in this graph we have some nodes which are connected through each other, and let's suppose we have some source node which is the 1, and we will go to the 1 to the 2 to the 3 to the 5 to the 7, or any kind of the neighbor. Maybe it could be 2 to 4 to the 6. So we will traverse like that. But what if we have some cycle over the graph? Let's suppose these two nodes are gets connected. Then what we have found that it is contains a cycle. So in this particular case, what we will do, we just initialize one more array which can be used to flag these particular nodes. Let's suppose got reached to this particular node which is the 3. Then we will what we will do that we just flag this particular node, and after that when we'll go to the 9, then we will flag this as well. We will go to the 10, we flag this, 8 flagged, 5 flagged, and again when we will come to the 3, then we found that we have already flagged this particular node. So what we found that this graph contains a cycle. So we will not iterate over this particular node, because we will initially check that is this node visited or not. This is the particular case we do in the graph. Um, so trees case is quite bit simple. Uh, in this case, basically, we have to just traverse row by row for the BFS. Like we have to just traverse its root node first, then we have to traverse the its second row, and then we have to just traverse its third row. Instead of row, we can also say that the level 0, level 1, level 2. So what will be the iteration of this, like what will be the result of this particular traversal? So we will get that 1, 2, 3, 4, 5, 6, 7, and you 100% got that. How I written that? Firstly we will go to the 1, then we will go to the 2, 3, and then we will go to the 4, 5, 6, and 7. So how this particular traversal works in the tree? So basically it works with the help of queue data structures, which is used to traverse in the tree, because queue follows the FIFO principle. And initially when we will start the traversal in the tree, we store the root value first before starting the all the traversal in the whole tree. We just store its root first, and we just apply simply while loop uh, over the whole array, over the whole tree. For that we have to just simply write some logic inside this, and during the end of the loop, during the end of the queue, we when we are just popping it, we have to just simply add more values like roots left or roots right. We can add into that particular queue, and during the traversal we can find all the results in this. So you might be uh, surprised like why we are just learning this particular algorithm, and is this algorithm only asks to the ourselves in the interviews only? So basically it's not. So basically this algorithm has some use cases, and these use cases are quite important in the software world. Like we can't survive without using the BFS algorithm for a minute. So basically, first and the major portion where it get used is the sort. finding the shortest path. Shortest path finding is one of the most important example for this BFS algorithm. We see in our daily life, like we just go from somewhere to somewhere with the help of Google Maps. So basically, use the BFS algorithm to find the shortest path between two nodes, and this includes particularly like Dijkstra or A-star algorithm as well. So this is one of the use case. Another use case is the web crawlers. Google uses BFS or DFS, we can say that also. The BFS algorithm basically links each web pages through each other with the help of the neighbor nodes. So when we just hit some query to the search box of the Google, then it results us some things, and we see that few pages are on the top, like few pages top, and then after this few pages comes. So basically these pages are linked with each other with the help of the BFS algorithm, and search engine ensures that we just clicked or we just scroll through one particular page. After that some particular page, like it basically those pages are linked with each other. So you have most probably heard or will heard that uh, SEO engineers have to learn about the BFS algorithm, because this is the one of the most important thing in their life, uh, to optimize their results into the search engines. The third use of the BFS algorithm is the NPM dependency resolutions. So most of you have definitely used the React.js or something node related projects. So there we have to install some NPM packages, and for those NPM packages we have to just make some dependency graphs. Those dependency graphs are just linked with each nodes or the values with the help of some nodes. So when we hit the npm install, then it just makes some dependency graph and it use the BFS algorithm, because with the help of BFS algorithm we can just reach to uh, a set manner of the dependency, like we have to execute first and then we have to execute the second, and like that. So this is how the so this is how we use the BFS algorithm in the npm dependency resolution. The fourth one use is the BitTorrent. You might have heard about this particular software, which uses the peer-to-peer terminology to spread out its data. Like when we hit download button to the particular site or something, um, in the BitTorrent site. It's basically use the BFS algorithm to extract data to its neighbors. Like unlike the some web servers or client server terminology, this basically different from those particular architectures. It basically follows the peer-to-peer terminology or technology to distribute its data to the its neighbor nodes. So basically, BitTorrent is quite bit important in the software world. So it uses basically BFS algorithm. The fifth and the last case of this is the AI. Uh, as in the current scenario, we see that AI is everywhere. AI uses the BFS algorithm to solve some complex problems. It can be basic ones, also like solving some Sudoku or puzzle. For solving Sudoku, we have to use the BFS algorithm. With the help of BFS algorithm, we can found all possible paths of the Sudoku or something. So Sudoku is the one of the most important use case for solving with the help of BFS, and AI uses this particular algorithm to solve these complex tasks. So this is how all the BFS works and what is its important. So you might have got some interest to learn these particular data structures in our life, because I think that before getting interested into some topic, we won't able to grab fully 100%. So firstly, we have to just develop some interest in the topic, and after that, we can just start learning it. So we can start it very enthusiastically. So thank you.